Hey everyone, Derek Korn here, editor-in-chief of Production Machining Magazine. Welcome to another edition of Production Matters series here running through IMTS Spark. Today I'm chatting with Scott Harms. He's president of MetalQuest Unlimited in Hebron, Nebraska. Hey Scott.
Hey.
So I've known Scott for a few years. Back when I was with Modern Machine Shop, their company was one of the winning companies for their Top Shops benchmarking program. So we wrote a profile about them in Modern Machine Shop. Back in January, I actually visited their operation there in Nebraska to write another story for Modern Machine Shop. But then he showed me, let's look at this new purchase that we just added here, this Index multi-spindle machine. So I kind of learned a little bit about that and kind of put that in my back pocket. Now it turns out I'm with Production Machining Magazine since the former editor-in-chief retired. So I said to myself, I have a pretty good story lead, and I think I know what I'm going to go after here. So they were in the November issue of Production Machining, just highlighting the hows and whys of adding that first multi-spindle. So Scott, why don't you've got the coolest background of any of these videos I've done. So give us a little background about your company, how you guys got started back in '96, and what's going on behind you and in your foyer.
Well, thank you very much, Derek. Yeah, we as a company really like to approach things a little bit different, and we really like to have fun in what we do. Our entire front office area, it's designed to kind of show where manufacturing came from. And unfortunately, there are so many negative stereotypes with manufacturing. I mean, people think about it, noisy, loud, dirty, all of those, the negative connotations that, have resonated over the years. And, we really want to try and show, maybe a little bit of the before and definitely the after, because when you come into our facility, it's a very, very modern, very clean, very high-tech facility. From a business concept, we're competing against China, we're competing against India, a lot of other low-cost countries. So we're doing our best to bring automation. We're bringing very efficient manufacturing to the United States. And we like I said, we try and have fun when we do it. So, this is our conference room that I'm in. This is a backdrop that we put in, just kind of showing where manufacturing came. We had a wall wrap put together in our front office area, basically our reception area. Again, going back to the roots, we've got a belt-driven lathe over there. We have belt-driven ceiling fans. We got a glass door, but you can kind of see right there. And it's Christmas, so Merry Christmas. We normally have a belt-driven grinder, which is right there. That's the real deal from the 1800s. The hand crank type stuff. And we put this in, again, as kind of a learning experience to show people that, this is truly where, things came from. This is our conference room table, which is cement. It weighs like 1,300 pounds, literally. We embedded parts in it and did some engraving, just to try and bring a lot of the stereotypes and a lot of the, the old concepts from manufacturing, as we show customers, as we show, schools, we're really big in education. So we bring tech schools in here, we bring high schools in here, and, a lot of different people to show manufacturing, it's not just this dirty, negative, stereotypical type occupation, that it truly is a tech type occupation with a lot of technology that requires a lot of skill, phenomenal attention to detail, and things that you can truly make a pretty incredible career out of.
So it's funny, the foyer kind of is like the old times where the roots, and then you walk back into the shop, and that's where all the kind of new magic happens with the robotics and the multitasking kind of concept of machining. So kind of talk about that. Like when you started in '96, like you didn't just start with standard lathes and 3-axis VMCs, did you?
No, and when you start a company, especially, something in competitive manufacturing, you have to do something different and you have to be different. In 1996, the very first machine purchased was a 3-axis lathe. Multitasking really wasn't even a word in 1996. And a 3-axis lathe, there were some out there. Obviously, we were able to buy one, but they just weren't common. Traditionally, you had your op 10 in a CNC lathe, you had your op 20 in a CNC mill, and that's just the way life went on. it's like you have to approach life in looking at the most efficient ways of doing it. And I was very young at the time, but looking at life in trying to figure out like the most efficient destination you want to get to. And we built the entire company to date off of multitasking, advanced automation principles, and trying to be efficient. Kind of like I said earlier, your competitor is not your neighbor. Your competitor might be a country halfway across the world. And we want to try and do everything we can to keep as much manufacturing in America as possible by using very intelligent, efficient manufacturing processes that are stable. Also, it seems like anytime you interrupt the process, you compromise the process. This is kind of a common sense thing. And going right back to the beginning, my goal has always been, and our entire team's goal has been, to reduce as many intangibles in the process as possible. And the more stable, the more consistent, the more predictable, and the more, how shall I say it, just like controlled the process is, usually the higher probability you're going to have for success within that process.
Mm-hmm. So we can maybe touch on, depending on if time allows later, about the wealth of automation there. You guys buy straight from Fanuc, the robots, you integrate them yourselves. You have your own proprietary in-house shop management system. We might want to touch on that a little bit later, but
sure.
You guys are geared towards more mid to high volume kind of work, aren't you?
That's correct. Being in rural Nebraska, labor is obviously a challenge. The type of work we've done and the type of automation we've put in place is trying to maximize the labor force that we have here and try and figure out growth paths, taking advantage of the area's good work ethics, and good mechanical skills.
So like I have a long list of questions here in my back pocket for Scott. But if anyone is on the line here today and they have questions, go ahead and enter those into the pane, and we'll try to get to those as soon as we can. But getting to the source here, multitasking from day one, very advanced equipment there, very automated. So what spurred you to think about a multi-spindle?
That is, the multi-spindle evolution occurred, and I realized, this is tied to IMTS, and I'm not making this up. This is not scripted at all. This is actually the way it happened. We probably looked at index multi-spindles and concepts like that, including hydromats, probably for about 4 IMTSs previous to doing anything. And again, I'm not just saying that because of this venue. It's true. We typically take quite a few people to IMTS from our company. Definitely our leaders from a technology standpoint that continue to push ourselves. And we stopped by the index booth and we looked at these. And kind of the evolution and how we got there is you look at these machines and you think, man, there's a lot going on. These things have to be complex. They have to be intimidating. And we started talking to some of the people in the booth and breaking down from a technical standpoint how these things operate, how you go about taking these things on. And, we think about it for a little while. And as our company grew, we started to get parts that, hey, this could be a good fit for a machine like this. And then we started looking at life from a business model standpoint and a competitive standpoint. I don't know how many shops there are that are like a traditional type machine shop. But there's a lot, right? And it's like, there's some that are small as, truly a guy in his literal garage, making parts from time to time, to obviously, very large, hundreds of employee type companies. You've got to make yourself differentiate from the competition. And, as we continue from a competition standpoint to see, the margins on our parts, always having pricing pressure put on them, and just looking at the way the business was going, we really, always had to take a step back and say, are we on the cutting edge, or are we doing this right? Are we doing it the most efficient way? The more we looked at the multi-spindles, the more we realized that when you get into that environment, you're not competing with thousands of shops, you're competing with tens or hundreds of shops. It's a much different world that is a little more, I guess there's just not as many players in there. And then we started breaking down the numbers and the dollars and the cents. A huge intimidating factor of a machine like this is the price of entry. we were really excited, when we started talking about price. It's like, oh man, it's like, we better reconsider this. We better, it's like, it's a serious investment, and I don't want to minimize that. It really is. But, it all came back to, it's like, when you start getting in the parts with some of the volumes that we're getting into, and you're starting looking at making these things, and from a cycle time standpoint, you start to run the numbers, and you look at that multi-spindle and the efficiency it brings. You've got to, it's kind of unbelievable. So, the easiest way of describing this to I guess, just the generic person or the average person, that machine obviously has a high overhead to it because it has a higher cost to it. It has brought so much cycle time reduction and increase in production throughput is probably the best way of putting it. Even with its higher rate, you take a machine that's fully depreciated. When you start factoring in labor, you have a cost per square foot for a building. You just do, and you start thinking about the overheads and stuff like that attached to each individual machine tool from an equivalent production standpoint. That, our index is always running at a higher profit margin than the equivalent conventional processes. And we're still talking about twin turret, twin spindle type machines. We're not talking about like 2-axis CNC lathes.
Right.
But, you look at a twin turret, twin spindle concept, and this machine is still running at a higher profit margin with a higher overhead because its throughput is that much greater. And, probably the easiest way of putting that in perspective, our particular machine has 62 controllable axes simultaneous. And that's kind of a mind-blowing number.
It is.
The part we're running right now is taking 59 of those axes. So you take a twin turret, twin spindle lathe. You've got a part in each spindle. You've got 2 turrets. In most cases, you're only doing 2 things at once. If you've got a Swiss, where you can do some other cool stuff, maybe you're doing 3 things at once. That's kind of the limits of your capabilities. 4 things at once might be the ultimate, maybe with a quad turret or something like that. And you're only doing that in such short bursts, it barely even counts, in a huge machine with a lot of floor space, or a Swiss machine, that's, highly, an expensive, highly complex Swiss machine. This machine naturally with 8 spindles, you're doing a minimum of 8 things at once, usually 9 things because of a synchron, and there's 2 synchrons on this. So you're always doing 10 things at once, and that's just to get started. You've got 2 slides per spindle. Most of the time you're doing, literally 15 to 20 things at once. And, from a floor space standpoint, it is disproportionate. Our twin turret, twin spindle lathes, obviously a lot smaller than this index. But when you start thinking about throughput, you take a part, that's got a decent amount of milling on it, stuff like that. You might be 6 or 7 minutes, and I'm talking like an optimized program. Where you're not wasting a lot of time, but you're still at about a 6 to 7 minute cycle time. You might be at 50 seconds at a machine like this, and it's like you start to add this together, and it's like 6 conventional machines worth of floor space is a lot more floor space than this single index. From there, you look about operators. It's like, I think everybody in the nation, even though we're in a rural area, I think all of us in this industry have trouble finding people. There's not enough people in this particular field. And it seems like, a lot of people aren't going into it like they used to. So you've got to take that into account. So then from a labor standpoint, I can have 1 person, 2 max, man an index. It's like, let's say you've got 2 people or let's say you've got 1 person manning 2 machines, and you're, getting about, 70, 80, maybe even 90%, efficiency out of those. When you start running the ratios again, you always have more people running a more conventional process. Again, even a twin turret, twin spindle being what I say more conventional than this. Your operator, the amount of operator involvement or the operator, like the individual human overhead, is always going to be lower on an index. Your throughput is usually always going to be higher, than the equivalent square footage, the equivalent cost, the overheads and all that of the more conventional process machines. And, it did take us a while to pay attention to these details and get over the sticker shock. But, we got this machine in November of last year. And if you check out our YouTube channel, you can see when the machine arrived, and, kind of did a little cool video how it laid in there. There was, we can go into this probably a little bit as well. There was definitely a learning curve when we got it. I would never say you could drop a machine like this in, on day 1 and be running parts, because, there's a lot to learn, and some of the approaches you need to take are different. But it's been probably the brightest spot from our company standpoint this year, just due to some of I guess, some of the successes and some of what I consider complete home runs we've seen on that machine.
Yeah. So you said day one, which is funny because when I did visit in January, I visited on day one of full production on that machine. So that was a bit of serendipity right there. And I was surprised and not surprised to see that machine there, having known kind of you and your shop's approach to it, going after advanced technology that other shops don't, just to diversify yourself. But talk about I think there was like one job that kind of was the initial impetus to this. Maybe I think it was a family of 5 parts
Yep.
that you were running on an advanced 3 lathes, but it made more sense eventually on the index. So maybe talk about that first job.
Yeah, you're absolutely right. So we do a lot of work in the hydraulics industry, a lot of more complex type parts. This part isn't super complex. It's got some burnished diameters to it. It'd lay in the palm of your hand and fit nicely there. Material's 12L14. We have 5 parts within this family, and the EAU on this, estimated annual usage, is about 450,000 between these 5 different part numbers. There was definitely one that was a higher volume. It's probably pushing 300,000 on the one itself, and then the balance consisted of about 150,000 between them. Yes, I mean, just like Derek said, we ran these on twin turret, twin spindle machines. We've been doing it for years. We got a great relationship with the customer. And there are several things that went into all of this. It's like, number one, we felt we had the price. We felt we had the part priced at a point where it was fair to the customer. And, obviously all of our customers, in this industry are under pricing pressure, it seems like. So, we maintained static pricing, for quite a few years. But going right back, like all of our individual companies' costs continue to increase. So it's like going to the customer and asking for a price increase, I didn't feel was probably something that would be fair to our customer. We started, our margins started to decline on this, again, higher volume, we've had to figure out a way to increase our margins. It was consistent, and that's, we've had this part for several years, and we looked at that and we said, this definitely won't fill an index up by any means, but, we've got enough history with this thing. We feel comfortable enough with it. We talked with the representatives from Index and said, would this be a good fit? And they said, absolutely, it'd be a great fit. And it's like, okay, so we started talking about cycle times, and this kind of goes back to what I was saying before. So in a twin turret, twin spindle machine, we were running between 1:15 to 1:45 vicinity, and depending upon the part, which one of those 5. The simpler parts were running 1:15, pushing in a minute 45, on the more complex parts with, more burnished features and more diameters and stuff like that. So we put this thing in the index, and yeah, right when, Derek came and he saw it, and, as we've evolved a little bit. So we went from cycle times like that to literally 17 seconds and 16 seconds. It was a phenomenal transformation. And honestly, we really, we haven't even fully optimized that, because we ended up dropping a couple other parts in the index that they're even better suited for it. But that was the difference in cycle time and throughput that we got, which was just mind blowing. We had goals and we had aspirations that, it would run it more efficiently and stuff. But when you actually start seeing that, and you start stopwatch down, it's like 17 seconds, click. It's like, click, there's another one and another one. It's like, wow, this is really something. And it really started to reinforce what we had been looking at previously, and where we had in our head that this looked like a much better way of doing it.
So that original part family, was that originally hex stock you were using, and then you switched it around?
Correct. We ran a lot of hex material. We have 12-foot bar feeders, hydraulically dampened bar feeders. One of the bigger problems we've had lately is, the straightness of hex material. All of the bar feeder guys, they say we're a bar feeder, we're not a bar straightener, and there's a lot of truth to that. And, we had difficulty getting that. Just because of the capabilities of the index, like with a 0 cycle time loss, we're now milling the hexes. We're milling the hex versus running hex material out of round. So yes, you do have a little more technical material costs, because the equivalent round material, you're buying more weight, but the consistency of the round material, usually the availability of round material is greater than hex. It ended up to be a no-brainer, and these are things that you can do, with a machine like that you just can't do in a more conventional, because you're doing much more sequential processing on a conventional machine, where you're doing much more parallel processing on a machine like this.
So yeah, so with the round two, like I would think that would simplify setups to new types of jobs. You just have the same diameter. You don't have to change out a bunch of collets and things like that. You just switch to another part program.
Oh, you're absolutely right.
Yeah.
And on top of that too, these parts weren't all out of the same material. We were running two different materials. So one was out of 15/16 hex and one was out of 1-inch hex. So we just ended up getting a round material that we could make both parts out of. And yes, you're spending a little more money in material, but your changeovers, as you just said, became exponentially easier. We have, there's eight main spindle collets on this. You've got bar pushers, liners and stuff like that. So yes, there is a huge advantage to creating a commonality amongst your material and amongst your parts and just building things in families, because your changeovers happen so much quicker.
So I remember when I visited, you mentioned something particularly unique with that bar feeder in terms of how it grips the end of the bar to minimize the length of the remnant you'd have at the end. Can you get into that a little bit?
Yeah, that was something that was really cool to us. And it's something that we had just, there's certain things that are thought through on this that you just never really think about because you're used to more conventional process. So the bar feeder we have on this machine is made by IAMCA. And they partner with Index and make a very specialized bar feeder for this. And again, just like you have 8 spindles, on your CNC machine itself, you have 8 bars that are all rotating simultaneously in your bar loader. And they've designed a very cool mechanism to continually load this and change your bar sizes from the bar feeder over very rapidly. But one of the coolest things that I saw on this originally, normally you think about like most 12-foot hydraulically dampened bar feeders. They have a collet that fits over the OD of the bar. So you basically, they pinch the bar and then they slide a collet over the OD. This actually does the complete inverse in this, and it holds the bar, just like you would. It's actually got a machining stage. Let me back up. It's more of a machining op. So it pinches the bar and it holds the bar, and it has an insert drill come in, and it drills just basically like a stub counterbore type hole feature in the end of your bar. And then it's got an expanding collet. So instead of gripping on the OD, it's actually like an ID collet where it's gripping on the ID. And there's several advantages to this. Number one, as Derek just said, it creates a very short remnant length. And where this comes into play, the job we're running right now is stainless steel. It's obviously got a much higher cost per pound than like a 12L14 does. You want to get as many parts out of each bar as you can. So by gripping on the ID versus the OD, you create a very, very short remnant length. It also helps your changeovers because your bar pushers and all of that, you're not near as tied to the particular size of material because you're creating an ID feature. It's the same ID feature that you create on a 1-inch bar versus maybe an 1 1/4 bar. And, you're continuing to push this and feed this thing through. Obviously you might need to change your cams and stuff like that in the bar feeder a little bit, but your pushers, it helps with changeover speeds as well. But it's a very robust, very intelligent way of doing it. You've actually got like a tool life management, tool life monitor on the insert drill on the bar feeder. And it's got a oil mist lubrication system and everything. It's actually like just a CNC drilling process that's within the bar feeder.
So you mentioned the video of the move-in, and I've seen that. We have a link to that in the online version of the article we wrote. It's pretty cool. I don't know how hairy that was for the. I know what that machine cost. I'm
Very
not going to
much.
say it right now.
Yeah.
But how anxious were you when that was maneuvered into your facility?
Well, it was wonderful to have it on the ground. I will say it was even the truck driver, he knew what that thing cost. He was very happy to get a signature to say that it was good to go. But yeah, you don't want to see that dangling through there. There's something, it's really actually not that heavy, relatively speaking, to what you think it would be, but there's just something about that thing dangling in the air that is just a very unsettling feeling.
Right.
You'll like them firmly planted on the ground and not dropped. Our riggers did a great job too. And, we gave credit to them in the video as well. They did an awesome job on that.
So I forget, did you have to move out machines to make room for the Index, or did you already have some real estate to put it to drop it in?
We did move. We shuffled some machines around. We didn't actually add any square footage, but we moved some machines around. And if you watch the video, we have air skates. Some people have not seen those before, but it just uses compressed air. If you think about like air hockey.
Air hockey, yeah.
Yeah, and it's like that's how we move all of our machines. And I think we've got a YouTube video of a horizontal machining center that's 55,000 pounds or something, just sliding in with 4 people moving it on air skates. It's kind of like surreal. It's kind of cool, but yeah.
Talk a little bit about Index and how helpful they were in terms of working with you through the purchase, training. Talk a little bit about that.
Well, that's a great point. And I want to give them a lot of credit because they're very conscientious of what this machine is and where this machine needs to go. And they told us early on, when we reached out to them in the very beginning, I remember very vividly. It's like, one of my guys came in and, I work with and said, hey, it's like, we've got some major capacity issues. We started talking about margins. It's like, we've looked at these things long enough. We got to give these guys a call. And I said, you're right. You're absolutely right. So pick up the phone and, introduce myself. And, the comment back was, it's like, do you understand these? Are you sure you know what you're getting yourself into? And it's like, we've done a lot of research. I actually told them the same IMTS story that I just got done saying here. I kind of told him where we were at as far as technology wise and stuff. And he said, yeah, it's like, sounds like you've researched this and it might be a good fit. And let's, continue the conversation. The relationship that we established with them was great. And, it's something that truly made this a success. A company like ours, even though, we understand, the technology and the automation side of things, we still didn't want to just buy this thing and just say, hey, just sell us a blank machine. We'll figure out how to run it. Because it's like, there's so much going on. So they helped us, set up the part, that we were planning on running in Noblesville, Indiana. And, we went there and did a runoff, and, it wasn't super expensive to do that. It's a service they offered, which I guess I wouldn't recommend it. I would like demand it out of anybody. It is like the highest recommendation that I could ever give. If a shop is looking at Index, is to work with them on something just like that. If it is your first purchase, there's no doubt. I'm gonna say when we purchase another Index, that we will, we don't have to necessarily go through that same process because we understand it now a lot more, but there's so much to learn. We did not have a Siemens control in the building prior to that. Just some of the tool holder concepts and some of the machining concepts that they use, some of the options that they bring to the table in terms of the control and the power of the control. You really kind of want to have those explained to you. You want to kind of have that set up, what I would call right the first time, or, kind of set up in a best practices manner. And, even though they might not get you like 100% efficiency on a particular part, they're going to get you close enough to where you'll understand what's going on and you can get it, where you need to. And besides, you're never going to hit 100% efficiency when you set something up the first time. You got to watch it, you got to learn, evolve, and stuff like that. But the relationship absolutely was great. And it's so important to establish that. We take relationships with our vendors very, very seriously. And this was something we felt really good about.
So like this is on my list down further, but let's jump around. I'm jumping around here a little bit. In terms of Index, and in terms of, you mentioned you had the original job, 5 parts in a family, but you've recently added another, perhaps more crazy job. And talk about the benefit of Index creating basically a digital version, a complete digital version of that machine to help you kind of implement that new job into the process.
And, that is a tremendous point. So obviously every minute with this machine you want to try and keep it running. You want to try and keep it in the cut and keep it in production. One thing that, this is, I would call like bleeding edge. They have a product called Virtual Machine. And Virtual Machine is literally a digital twin to this machine tool down to the serial number. So you've got, it's essentially a CAD system of sorts, but it's the actual, it's a software the machine tool itself has. You have that on your PC. All of the tool holders, all of the different combinations of live tool motors and different things that you can do with that machine in a physical sense. They've got STL files on their website. You grab these STL files and you literally tool this machine up in a virtual environment. And it's one of those things, it's so cool. You kind of have to see it to just like really believe like, oh my God, this is real. you can check all your interferences. There's great ways of doing that. You can literally stop processes midway through. You can measure the part, virtually and make sure that things are right. Obviously zoom in just like a 3D CAD system would allow you to do. The thing is, it's like you're not just building this in a 3D environment. You're literally writing the program. Like every detail that you have to do on the machine, with maybe the exception of coolant lines, I mean, it's to that level, you can build in virtual machine. So when that thing hits the floor, when that program hits the floor, you're transferring this directly out of virtual machine into the machine tool itself. You have a setup sheet established. You know exactly what you're going to be doing. You've got cycle times figured out. Assuming from a cutting standpoint that you've got a sound process, and things don't happen unexpectedly there. You have an ultra high probability of hitting the ground running and making the part right the first time. Where this came in handy tremendously is the part that we're running right now. It's got a lot of milling on it. This machine has got 4 of the slides have a y-axis feature. We're using the y-axis slide on 3 of those slides on the part we're making, if that kind of puts it in perspective. There's a lot going on. I think it took our guys probably 2 to 3 weeks on virtual machine, which sounds like a long time because yeah, it's a complex setup, but this was one of the first setups they had done, and period. And it's like this was kind of a Mount Everest type project for us, and we tackled it up front. This thing was fully programmed. This thing was fully tooled virtually. It's like they hit the machine knowing where every bolt was going to go into it. I can't even express the level of power that is, efficiency that is. It ran production on the part that it had in it up until the last minute. And when we took that machine down, it's like we knew exactly what we were going to be doing. We literally had, all of the tooling was organized beside that machine, ready to go in, exactly knowing where it was going to go. You don't have to prove out interferences. You don't have to, obviously you run it slow the first time, but you don't just hit go. But regardless of the fact, it's like you don't have a lot of hidden surprises.
So you speaking about tooling, you and other costs, like this machine was a significant investment. Coolant was a significant investment alone, but you also purchased a Zoller presetter that I believe was designed pretty much for this type of machine. So I want to hear about that, but first I want to hear about your approach to presetting in general, even before you got this index machine. It seems like some shops of your size might not think a presetter is, maybe they're not ready for a presetter. Maybe they don't think that they need one. What would you say to shops like those?
So, that's all excellent points. And, we could do segments, on those particular subjects, just to kind of put it in perspective. So our company started in 1996. We put our first presetter in 2006, and just literally exactly like you were saying, we always thought it's like, hey, we're not big enough for a presetter, because that's the #1 misconception that, you're just as a company size, yeah, they'd be nice. And maybe when you grow bigger someday, you can have some and, have a tool crib attendant, and that'd be really cool. We're just not there yet. And, we just touch off tools, either the old fashioned way, we've got tool like touch off probes and stuff like that in some of our machines, but you just go about it in the more conventional thought process. And the more we learned about presetters, we developed a relationship with Zoller, and the more we learned about them, we realized it's like, no, we should have had a presetter years ago. And that's the honest to God truth. The presetter was such an interesting thing to put into our company, because I think it was probably because of the size we had grown to at that point in time. It was one of the more complex things to put in. And I don't say that in a bad way. I actually say it like we approached this from a ground up. Like, we want to lay this thing in the most efficient way possible for the long term. So that means changing a lot of our processes. It means changing bad habits. It means rethinking things. So we lay this thing in, and it's like, we never look back. We actually added another one right after that, as far as our just the conventional Venturian, the conventional style presetter. And when we looked at this index, you've got to take uptime into consideration with any of your machines. So many people, from a presetting standpoint, they index their inserts and stuff like that in the machine tool. Maybe you change out your tools on your Cat 40 tools, and you do this, way more times than you should while the machine is stopped or the process is stopped. We've all dropped a screw. I mean, it's like you drop one of those little insert screws, like, where did it go? And now I got to find another one. I mean, this is all downtime. We started to realize the fact, it's like you have a preset tool sitting there right by that machine, ready to go. If it's a production job, or if it's an initial, like it's a short run setup job, you walk up to the machine, you've got every tool touched off. And, you start using digital transfer type techniques to where you're transferring data from the preset to the machine tool itself. It's kind of I'm not gonna say it's life changing and blow it out of proportion, but it's like, from a manufacturing concept standpoint, it really does redefine. And you start to look at yourself like, my God, I can't believe I used to do things this way, because it's so much, I guess, more robust of a process when you break it down. If you get a CNC presetter, you can have that presetter, actually look at that tool from a measuring type concept and from an inspection type concept, and get data that, you're just not going to do on the shop floor. You take a shell mill. It's like, we've all touched shell mills off. It's like with your presetter, let's say you've got 5 inserts on a shell mill. I mean, it's actually, grabbing the insert that is the farthest from your gauge line, and it's basing the offset, off the insert that truly makes sense. These are things you just don't do on the shop floor. It allows you to make sure that your inserts are, on a shell mill going back, or within a given range. So yeah, this could be a segment in itself, but it really made us rethink, like, why didn't we do this a long time ago? Now you evolve that into the index, and it's like, an index, it is every, like, how do I want to put this? An index could be every bad habit you have on the shop floor on steroids for the exact same concept. First of all, it's like, tool changeovers on an index are a much bigger event than they are on a conventional lathe. Because it's like, on a conventional lathe, everything is happening, for the most part, sequentially. In an index, it's happening parallel. So you've got a lot more tools in the cut simultaneously. We've used tool life management on our machines really since the beginning of the company. And that's something, I see a lot of people that still don't do it. And I guess I don't understand why they don't do it, because, you want to try and control the process however you can. You have to use tool life management on index. I mean, there's just not an option not to. So you start to think about, every time that door opens, again, that's an intangible. It's an inconsistency, and you're affecting the environment. By having a lineup of preset tools, and especially going back to the digital communication back with a presetter, you open that door, you've got your tools lined up, ready to go. Index has done a very, very good job creating very repeatable work holding concepts. Like, you guys are probably familiar with, like, Sandvik Capto, Kennametal's got KM series, these are quick change tools. Index has got some proprietary ones as well that they use. The type of presetter that we purchased for this machine is actually, it's literally 90 degrees rotated, versus like the conventional Venturian type, where you've got the cameras set up, more conventional towards machining centers. This presetter looks much more like a turret lathe, to be flat honest. And you've got a turret with different stations, and these different stations have blocks that hold the different tool holder concepts and work holding type concepts, or I guess, yeah, tool holder, like the way the tool holder type concepts mount. You've got multiple selections of those on this turret, and your camera is set up to make sure that you can do like your height, your center height checks and stuff like that. You still write CNC programs just like you would on the conventional CNC presetters, but it allows you to come up, inspect the tool, make sure that the thing is set up correctly. So when you go to the machine and you open that door, you've got these tools literally lined up, ready to go. Quarter twist maybe on a Sandvik Capto. Index uses it's a type of VDI called WVDI for your live tooling and stuff like that. So most people aren't used to changing like a live tool head in a quick change fashion. With an index, you really want to. So we're actually presetting the complete live tool with whether the end mill or the drill or whatever in it. It drastically reduces your cycle times, or your tool change times. I'm sorry. It drastically reduces your tool change times, relatively speaking, versus if you were going in there and indexing inserts, one by one, and changing, tightening and collets and all that sort of stuff.
Yeah. I think I remember you mentioning in terms of the Zoller for the index, the presetting software is pretty powerful too, to where you can get into more. I mean, I mentioned the proprietary shop management software that you guys have developed, but kind of even migrating some capabilities from that in-house software to the Zoller software. I don't know where you are in terms of that development, but talk about the advantages of the software for that particular presetter.
Well, it allows you to build setup sheets, actually truly build setup sheets. And, you know, if you're only doing one part one time and you know that, a setup sheet is a lot less important than if you've got a job that will repeat. And you know, the bigger your company grows, you know, the more important documentation and the robustness of your documentation matters. It's also important to be able to create this documentation in an efficient manner, because you don't want documentation and you don't want this stuff that's really cumbersome to create, because it'll never get done. So by incorporating this directly into the presetter, you know, it allows you to build these components, you know, at the presetter level, put them together, create your setup sheets, and create a much better organizational, I guess, toolkit for the job as a whole. So yeah, that's tremendously important. We've extended that. We have electronic vending machines. They're made by Supply Point that dispense our tools and perishable tools, you know, drill bits, different things like that. That's all tied into that as well. You know, that helps build reorder lists at that point in time. So yeah, we've taken it down to that level to where, you know, our purchasing guys, you know, literally get reorder reports from our electronic vending machine, which, you know, actually comes from the presetter to some degree. You know, it takes so much human element out of it. And I don't mean that in a bad way that it takes people's jobs. It's just, it's really making the people's jobs very efficient, you know, and very consistent.
You guys you set up a pretty slick gauging system right next to the machine itself too. Talk a little bit about that.
That is a great point. So when you're making parts, you know, as I said, you know, we'll say 17 seconds, or let's say you're making a part every 30 seconds and it's got 50, 60 dimensions on it, which is not uncommon for some more complex parts. You can run scrap parts really, really fast. Everybody knows that. Because guess what? You can run scrap parts just as fast as you can run good parts. You need a robust gauging system, and you need to rethink how you do your gauging. So, you know, a lot of people think SPC, again, going back, you're too small of a company to be implementing stuff like this. You know, you rethink this process and you actually create something that's much more efficient and much more usable. It's like human nature itself. The more usable, the more efficient a process is, the more likely it will be used. The more cumbersome, the more burdensome is, the less likely that process will be used. So when you approach, you know, a multi-spindle machine at that volume, at that throughput, you've got to figure out gauging that can be done just as fast. And it doesn't necessarily have to be automated. You know, we've got digital travel dials tied into an SPC system. We've got digital mics, you know, they've got stands, you know, and we just created a flow chart, we'll say, like a process flow chart, to where the operator goes through each individual station, you know, measuring these key characteristics. You know, they pretty seamlessly get inputted into the system. And, you know, it allows the operator to see, you know, very automated and very, you know, visual. It's like, hey, there's a problem. It's like, you know, all of us at one point have read a micrometer wrong. You know, you don't want to do that, but it's like, you know, you look at them long enough and, you know, it's bound to happen. And, you know, this just gives you a visual alert and a visual warning. And it's one level of redundancy. But yes, that's another tremendously important characteristic, because it's easy to miss that aspect. It's like, hey, great, we're making parts this fast, but we can't inspect them. And I don't mean full, yeah, exactly. I don't even mean 100% inspection on this stuff. I mean, just like a typical sampling plan. You know, let's say you measure parts every 30 minutes. When you're making parts that much faster, that 30 minutes just, I mean, it might have turned into 5. And you definitely need to figure out a way to get that done efficiently.
Yeah. So I'm sort of running out of questions here. If anybody watching has any questions, feel free to type them in. But like Scott, so is there anything you might have done differently in bringing this online in your shop? Or is there any advice you'd give other shops that might be on the fence in terms of making a serious investment like this?
You know, I guess, and this just hit my head this second. One thing that's easily overlooked in any machining process, and most people don't really pay a lot of attention to is chip control. I know all of the carbide guys, you know, the insert guys and all of that, everybody talks about chip breakers and they talk about chip control, and, you know, everybody is really helpful. But at the end of the day, you know, when you've got a parting tool and you've got a machine where, you know, like you're making a ribbon stringer or whatever, and that thing is falling right in the conveyor, you know, it's going out of the machine, you know, we've got it happening here. Everybody has it, you know, especially the more, you know, stainlesses are notorious for that, you know, groovers, you know, threaders, you know, they're hard to break a chip. You need to break a chip on an index. I mean, any multi-spindle application like that, it becomes very, very, very important to break a chip, because if you're creating bird's nests, that bird's nest becomes a giant bird's nest, and it does it very, very fast, and bad things happen. So that's one easily overlooked aspect of a multi-spindle. You know, paying attention to chip control. You know, the stainless job, you know, this is kind of it's a funny story, but the stainless job that we were just on, you know, we love high pressure coolant. We use high pressure coolant a lot. This particular machine has got a high pressure coolant side to it, and it's got, you know, a lower pressure coolant side. So we were actually using this is a Sandvik Capto head, and it's very focused. You know, having I think it was actually the through coolant clamping mechanism, like, I mean, very directed. You know, getting high pressure coolant on the chip, and this was on a finisher on the stainless. We weren't breaking a chip; it was causing a problem. We brought the insert rep out. Super helpful. We actually took the high pressure coolant off and put low pressure coolant on. Got more heat in the chip. Boom! We were breaking a chip. Little things like that, you know, it definitely takes time to tweak the processes out, you know, and going back to process control, it's like once you tweak the processes out, you don't just buy this insert because it's the cheapest for, you know, you don't buy the flavor of the day insert, you know, for this particular machine. You develop a process and you stay by that process, and, you know, and keep it going. But yes, one thing that's easily overlooked on that is just the importance of chip control. And the more difficult material you have to machine, the more difficult technically, you know, usually traditionally it is to break a chip. The more attention you need to pay on that on the front end. And that then the service and support, you know, goes all the way down to the different cutting tool manufacturers you use, and, you know, making sure that you have good service and support there. But yeah, that's one thing.
So, so like, what's next on the horizon for you guys? What do you, is there any new equipment, any new changes? What are you eyeballing?
So that's a great, 2020 has changed a lot about, you know, all of our companies. You know, we've obviously got customer sectors that are down. We've got some that are going strong. But 2020 has made us completely look at our company and figure out, we've made it 25 years. You know, 2020 has changed the rules for a lot of people in a lot of ways. Unfortunately, some companies I don't think are going to make it through it. You know, we're going to. It's like there's no ifs, ands, or buts. You know, it's like, how are we going to make sure to, you know, be able to survive a 2020 if it happens again? How are we going to position ourselves, you know, into the future? That's what that is evolving into is, you know, creating an entity that's an extension of our company in a different location that's going to specialize in more one-off style, more prototyping stuff, getting into sectors that we're not currently in, that we haven't been technically really able to compete in just because of the workforce and stuff like that we have within this area. So that's a huge evolution, is literally creating kind of a new division of our company in a second location. So that's a huge challenge. We're really excited about it. We've built pretty much that through this entire year. We've been working on that. And it's something we're just really announcing right now over the last couple of weeks, and I'm going to kick it off in January.
Cool. So we're coming up on the top of the hour here. And this has been fun. Like, there are so many other things I could ask you right now. There's so much going on underneath the roof there at MetalQuest in Nebraska. Like, I wanted to ask, I know the answer. How do you store a 55-gallon drum of coolant in a vending system? we can get into that maybe some other time. But Scott, is there anything else you wanna say? Is there anything I did not ask about in terms of your company or the index machine in particular?
You know, you did a great job, and I guess, you know, thank you very much for all the support you've given us. You know, going back to our logo, you know, our logo is like an arrow pointing out of the box. You know, we really try and approach everything, you know, we do with an out of the box mentality. Yeah, there you go. Exactly right there. You know, it's very important to us. you know, to me, it's like when it comes to a company, you're growing or you're dying. And unfortunately, there's not a lot of middle ground. And when you become complacent, you know, it's kind of dangerous. And we've always been trying to stay on the leading edge. We've always tried to push ourselves. You know, like I said earlier in the segment, I guess, you know, I have high standards for myself. You know, I have high standards for my team, and they're not unobtainable standards. They're trying to do the best you can. It's like, you know, our motto is, you know, striving to be better tomorrow than we are today. You know, I guess, as I mentioned, within 2020, it has changed the rules so much, and you know, we've all had to relook within ourselves and you know, make sacrifices to survive, and you know, change the way you do business. And I guess I would say that sometimes, you know, you got to go through the rough times to make a better company. And I guess, you know, to me, it's like we're using this year, we're learning from this year. You know, every time we've been down historically, which has only happened a couple times, but we've reinvested in ourselves. That's exactly what we're doing right now. It's like, don't just get down about this year. Don't get down about things. You know, come out swinging. And I truly believe there's going to be a strong recovery, hopefully in 2021. And we're going to position ourselves to make the most of it. And I guess I'd encourage, you know, everybody to do the same thing.
Great. Scott, I appreciate you taking time today. Like, if any viewers want to learn more about MetalQuest, it's metalquest.net, not .com, I believe,
Yep,
right?
Yep, that is correct. MetalQuest.net.
.net. And any stories related to this type of application, if you're interested in, productionmachining.com. So outside of that, again, Scott, I appreciate you taking time, and I hope everyone has a great day.
Yeah, well, thank you very, very much. And yeah, take care.
Thanks, Scott.
Yep.